I'm going to show you another distance problem. So in this case we have, before I begin, let me remind you that distance is equal to the rate times the time traveled. So that's distance is equal to the rate you're moving, or someone or something is moving, times the time that they are traveling. So in this particular case, we have that Carrie drove to the mountains, averaging 48 miles per hour. Coming back on the same roads, she averaged 40 miles per hour, and the total driving time was 11 hours. How far did she travel? So we need to set up our table. And so I'm going to put the first part, I will call it what type of drive, which drive was it? Was it her drive to the mountains or from the mountains? And then I need to have a space for my distance, or a column for my distance, for my rate, for my time, and then for my final formula for each one. So D equals RT. So looking at rate, because that's probably the first thing that pops out, is when she was driving to the mountains, she was going 48 miles per hour. When she was coming from the mountains, she was going 40 miles per hour. Because she came back by the same roads, we know that means that the distance on both of those is going to be the same thing. So I'm going to call both of them D because they are the same thing. The distance was the same on both. Then for the time, on the ride to, I'm going to say that we're just going to call that T, because we can call something we don't know by a variable. That's what we always want to do. When we don't know something, we give it a variable. And since we're dealing with time, I'm just going to call it time. But then we need to figure out how we can name the time that she spent coming from the mountains. How much time did she spend coming home from the mountains? Well, I know that the time going to, so this time, plus the time she spent coming home, so I'm going to call that time 2 because it's the second drive. I know the time going to the mountains plus the time coming home from the mountains was 11 hours. So I'm going to call that is equal to, let's say T plus T2 equals 11. But I'm trying to figure out what was T2 so I can put it in this table. So what I'm going to do is subtract T, which was this T. I'm taking this one away so that I only have my T2, my second drive. When I subtract that, I'm left with time, the second time, is equal to 11 hours minus however many hours that first T was. So that means that instead of saying T2 here, I'm just going to call this 11 minus T. All right, so let's put together our equations. So then we have that D is equal to our rate, which in the first drive was 48 miles per hour, times the amount of time that it took her to drive. And then I'm going to do the same thing with the second one. I have that my distance is equal to, now this time she was going 40 miles per hour, times, now in this case we have this whole quantity that we have to multiply by. So instead of just T, we have 11 hours minus T, because remember it's this original one is T. So the 11 total hours minus the drive there is going to give us the amount of time she took to get home. So we're going to go ahead and set up our equation now that we have the information that we need. I know that these two D's here are equal. These distances are equal to each other. So that means that what they are set equal to, so this distance is equal to 48 times the time. This one is equal to 40 times 11 minus the time. But these are the same, and since they're equal to these, that means that these are the same. So that means I can say that 48T is equal to 40 times 11 minus t. So I'm going to go ahead and distribute here so that I can go ahead, so I can solve for my time. And remember, this t only represents the time going to the mountains. So I've got 48 t is equal to, what is that going to be? 440 minus 40t. When I distribute that, I get 440 minus 40t. I want to get my variables on one side. I only want variables on one side, so I need to get rid of the variables on this side. In order to do that, I need to add 40t so that those cancel out. Anything I do on this side, though, I have to do on this side as well. So what I get is 48 plus 40t gives me 88t is equal to 440. Now I want to get my my variable t. I want to get that on its own. So I need to divide by 88. When I divide by 88, 88 over 88 is just 1, and that's times t, so I have t is equal to 440 divided by 88 is equal to 5. So I have that the time, t equals 5. Well, that's telling us that it took her 5 hours to drive to the mountains. Because remember, t represents her time going to the mountains. But what is it asking us? It's asking us how far away did she travel? That's not what it's at. We didn't answer that question yet. So if I know that she drove 5 hours to the mountains, and I know that going to the mountains she was going 48 miles per hour, then I can figure out what the distance that she traveled, because I know that the distance is equal to the rate times time. So I can say, since I know that distance is equal to rate times time, and I know that her rate going to the mountains was 48 miles per hour, I can plug that in for rate. So that's 48 times the amount of time she spent going to the mountains, which was 5 hours. So I'm going to plug that in, 5 hours. So 48 times 5 ends up giving me the distance equal to 240 miles. And remember, when you have a question that is posed to you in words, you should answer in words. And if you have a word problem, I want to answer that is in words as well. So our answer is, and remember the direct question was how far away did she travel? We can say that Carrie traveled 240 miles and that's good enough. Hope that helped.